This is Chapter 8 practice exam number 7. An ice skater with a moment of inertia of 7.5 kilograms per meter or kilogram meter squared makes 3.8 rotations in 2 seconds. I want to know his angular momentum, his rotational kinetic energy, and then we're going to change the moment of inertia, and I want how many rotations he completes in 1.95 seconds after that. So I've copied the pertinent information over here. So first off, let's find angular momentum. Well, the magnitude of angular momentum is moment of inertia times angular velocity, or speed since we're just doing magnitude. So, well, I've got that. I've got I need omega. So I is 7.5. Okay. Omega is supposed to be radians per second. Well, what I have is I've got 3.8 rotations per 2 seconds. I need to multiply by 2 pi radians per rotation. Okay, so that the rotations cancel out and I'll be left with radians per second, which is what I want. So this should be it. I times 3.8 times 2 pi over 2. Oh, interestingly enough, the 2's cancel out. I'm going to go ahead and do that. 2 is gone. Okay, so really what I have is 7.5 times 3.8 times pi. All right, let's try that out on the calculator. And I get 89.5 kilogram meters squared per second for the angular momentum. Okay, how about the, oops, that's a B. That should be a B. Rotational kinetic energy is next. Well, rotational kinetic energy is 1/2 I omega squared. Well, I just did omega down here. I'm going to kind of skip through that a little bit. So I've got the 1/2 I. I'm going to leave the units off this time just to save space and time. And I've got the 3.8 rotations over 2 seconds times 2 pi radians. I'm just going to go ahead and throw in the 3.8 pi and squared. Don't forget the square. Don't forget the square. Okay, put that in the calculator. And I get 534 joules. That's a 5. Okay, now C. There's actually 2 steps we have to do here. Okay, first off, when an ice skater pulls their arms in, they're just on ice. There's no outside torque from like friction or anything. So momentum has to be conserved. That means the momentum I start with has to equal the momentum I finish with. Well, I already know what momentum I started with. I started with this over here, 89.5. Okay, then the momentum I end with is going to have to be my final moment of inertia times my final angular speed. Now, final moment of inertia I've got. It just tells you what it is. Okay, so 2.4 times omega final. Okay, so omega final is just going to be 89.5 over 2.4. Okay, and that gives me a number. I guess I could find it. It is 37.3 radians per second. But the thing is, that's not what I asked for. I want to know how many rotations does this ice skater do in 1.95 seconds. So first off, let's find out how much angle they go through. So let's change colors here. Yeah. Okay. Well, at a constant speed, so that's this, theta would be omega times time. Okay. Actually, it'd be this, but at a constant speed, that's 0, so we don't care about this last term. Okay, so that's going to be 37.3 radians per second times 1.95 seconds. That gives me 72.7 radians is what I'm going to go through. The question is, how many rotations is that? Well, rotations, change colors again. Let's go this color. This funny color. 72.7 radians, there is one rotation per 2 pi radians. So all I have to do is divide by 2 pi, and that will get me my answer. Be very careful when you're dividing by 2 pi that you divide by the quantity 2 pi, don't just hit divide by 2, don't just hit the divide button, then the 2 button, then the pi button, because that would divide by 2 and then multiply by pi. So don't do that. Anyway, I get 11.6 rotations in the end. Okay, let's talk about points. Well, I want at least 1 point per answer. So we've got a point here, and a point here. So there's 3 points right there. I also want a point per equation used. So a point for showing the equation for angular momentum, 1 for rotational kinetic energy, and then there isn't really an equation for C, but you just need to show me somehow that momentum is conserved. Either say it in words, or say it in an equation like this, or you could just write I initial, omega initial equals I final, omega final, something like that. Okay, I also want a point for converting the original, the original rotations per second into radians per second. Either you do that inside one of these equations, or you just do it off by itself somewhere. I don't really care which one. Then how about a point for putting in the correct initial momentum from part A? So this way, if you go wrong by, you get something wrong, part A wrong, and you put that wrong answer in the correct place in part C, you'll still get a point. And then let's see. I think that's 8. Let's do correct units on parts A and B. Yes.